Hello smart civil engineers. I'm Engineer Masroor and you are watching Engineering Network YouTube channel. I'm back with another important topic. So in today's video, our topic is how to calculate the quantity of earthwork, quantity of PCC, brickwork in foundation, sand filling in foundation, and DPC. Now this is basically the second part of complete estimation of house. Okay? So kindly watch this video till the end for better understanding. So in today's video, I will be showing you how to calculate the quantity of earthwork, PCC, brickwork and sand filling in foundation and also the quantity of DPC. Now before I start this very important video, I have a request from you guys. So if you find this video informative, then please like this video, share it with your friends. And if you are new to my channel and haven't subscribed yet, then please click on the subscribe button and also make sure to press the bell icon for more civil engineering videos. Okay, so in today's video, our topic is how to calculate the quantity of earthwork, PCC, brickwork in foundation, sand filling in foundation and DPC. Now in the first part of complete estimation of house, I have briefly explained the basic concept of the centerline method and also I have calculated the total length of the centerline as well, which is 185.5 feet for this particular house. Okay, so in this video I am also going to show you how to identify and deduct the junctions from the total length of the center line. Okay, so first let's identify where we will take junctions in this house plan. So the junctions should be considered for those walls whose ends are not meeting with each other. Okay, so as you can see here, the ends of these two partition walls are not connected with each other, right? So according to the center line method, it states that if both ends of a wall are not connected with each other, then both ends of that particular wall will be considered as junctions. Okay? So here in this house plan, one junction will be right here, one junction will be here. One will be here and one junction will be right here. Okay, so basically I have 4 number of junctions in this house plan. Okay, now after identifying the number of junctions, now let's explain the cross section for this particular house, right? So as you can see, this is the cross section for this particular house. Here in this cross section, I will provide a layer of lean concrete or PCC at the bottom of foundation. Okay, the width of this PCC layer is 1.5 feet and the thickness of PCC layer is 0.75 feet. Then I will provide 3 steps of brickwork in foundation. Okay, so the width of step 1 is equal to 1.25 feet. And the height of step 1 is equal to 0.75 feet. The width of step 2 is equal to 1 feet and the height of step 2 is also equal to 0.75 feet. The width of step 3 is equal to 0.75 feet and the height of step 3 is equal to 0.75 feet. Okay. Now the step 3 will be constructed up to the ground level and above step 3 I will provide a 3-inch thick DPC layer and the width of DPC layer will be same as the width of step 3, which is 0.75 feet. Okay, so this is a brief explanation of the cross section for this house. Now it's time to finally start calculating the quantity of materials for this particular house. Okay, so at number 1 is the quantity of earthwork. So the quantity or volume of earthwork is equal to length into breadth into height. Okay, Here I will calculate the length for the earthwork, because in the earthwork I have to deduct the junctions of these two partition walls from the total length of the center line. Okay? So the formula for the length of earthwork is equal to total length of center line minus number of junctions into width divided by 2. Okay? So here the total length of the center line is 185.5 feet. Number of junctions are 4. Width of the earthwork is 1.5 feet. Right? So the length of earthwork will be equal to 185.5 minus 4 into 1.5 divided by 2. And after calculations, the total length of earthwork will be equal to 182.5 feet. So the length of earthwork is 182.5 feet. Also the width of earthwork is 1.5 feet. And the total height of the foundation is 3 feet, as you can see here in the cross section as well. So after putting the values, the volume or quantity of earthwork will be equal to 821.25 cubic feet. So now I can say that for this particular house, the quantity of earthwork is 821.25 cubic feet. Now after we calculate the quantity of earthwork, next is the quantity of PCC. Okay? So the quantity or volume of PCC is equal to length into breadth into height. Here the length of PCC layer will be same as the length of earthwork. Okay? Because if you look at here, the PCC layer will be provided along the full width of the earthwork or excavation. Okay, which means that if the width of earthwork or excavation is 1.5 feet, then the width of PCC layer will also be 1.5 feet. Okay, so because of that, the length of PCC layer will be same as the length of earthwork. So the length of PCC layer is equal to 182.5 feet. Width of PCC layer is 1.5 feet. And height of PCC layer is 0.75 feet. Okay, so the volume of PCC layer will be equal to 182.5 multiplied by 1.5 multiplied by 0.75, and it will become 205.31 cubic feet. Okay, so the total quantity of PCC layer is 205.31 cubic feet. Now this is the wet volume of PCC, and in order to calculate the quantity of cement, sand and aggregate which are used in the construction of this PCC layer, I have to convert the wet volume of PCC layer into the dry volume, right? So the dry volume is equal to 1.54 times the wet volume. Here wet volume of PCC is equal to 205.31 cubic feet. So after putting the values, the dry volume of PCC will become 316.18 cubic feet. Now for this particular house, I am using M20 grade of concrete. Okay, and we know that the mix ratio of M20 grade concrete is 1:1.5:3. And the sum of ratio is 5.5. Okay. Now I can easily calculate the quantity of cement, sand and aggregate, right? So the quantity or volume of cement is equal to 1, which is the ratio of cement in the mix ratio of M20 grade concrete, multiplied by 316.18, which is the dry volume of PCC layer, divide by 5.5, which is the sum of ratio. So the quantity of cement in PCC is equal to 57.48 cubic feet. Next is the quantity of sand. So the quantity of sand is equal to 1.5, which is the ratio of sand, multiply by 316.18 divided by 5.5, and the quantity of sand will be equal to 86.23 cubic feet. Similarly, the quantity of aggregate is equal to 3, which is the ratio of aggregate, multiply by 316.18 divided by 5.5, and the quantity of aggregate will be equal to 172.46 cubic feet. Okay, so these are the quantities of cement, sand and aggregate used in the construction of this PCC layer for this particular house, right? Next is the quantity of brickwork in foundation. Okay, so for the brickwork in foundation, I'm actually going to construct 3 steps of brickwork, as you can see in the cross section of this house as well. So the quantity of step 1 will be equal to length into breadth into height. Here the length is equal to 185.5, which is the total length of the center line, minus 4, which are the number of junctions, into 1.25, which is the width of step 1, divided by 2. Okay, and the length of step 1 is equal to 183 feet. So the volume of step 1 will be equal to 183 multiplied by 1.25 multiplied by 0.75. Okay, and the total volume of step 1 will become 171.56 cubic feet. Next is the volume of step 2. So the volume of step 2 is equal to length into breadth into height. Here the length is equal to 185.5 minus 4 into 1 divided by 2, and the total length of step 2 will become 183.5 feet. Okay, so the volume of step 2 will be equal to 183.5 multiplied by 1 multiplied by 0.75, and the total volume or quantity of step 2 will become 137.625 cubic feet. Next is the volume of step 3. So the volume of step 3 is equal to length into breadth into height. Here the length of step 3 is equal to 185.5 minus 4 into 0.75 divided by 2, and the total length of step 3 will become 184 feet. So the volume of step 3 will be equal to 184 multiplied by 0.75 multiplied by 0.75, and the volume of step 3 will be equal to 103.5 cubic feet. Okay, now the total volume of brickwork in foundation is equal to volume of brickwork in step 1, which is 171.56 cubic feet, plus volume of brickwork in step 2, which is 137.625 cubic feet, plus volume of brickwork in step 3, which is 103.5 cubic feet, and the total volume of brickwork in foundation will become 412.685 cubic feet. Okay, now we know that in 1 cubic feet we need 13.5 number of bricks, right? And I have already uploaded a detailed video about how much bricks are required in 1 cubic feet. Okay, so kindly watch that video for better understanding on my YouTube channel, and also you will find the video in the I button or in the description of this video as well. So the number of bricks that will be required in the brickwork of foundation is equal to total volume of brickwork in foundation, which is 412.685 multiplied by 13.5, and the total number of bricks in foundation will become 5,600 bricks. Okay, so now I can say that in brickwork of foundation for this particular house, I will need 5600 bricks. Now after that I will need mortar in order to place these bricks in foundation. Okay. So next is the quantity of mortar in foundation. And for mortar I am using the mix ratio of 1:4 and the sum of ratio will be 5. Okay. Now we normally take mortar as 30% of the total quantity of brickwork. So here the total quantity of brickwork in foundation is 412.685 cubic feet, right? So the quantity of mortar is equal to 30 divided by 100 and multiply by 412.685. And the total quantity of mortar for brickwork in foundation will become 123.80 cubic feet. Okay. Now this is the wet volume of mortar, right? And in order to calculate cement and sand and mortar, I have to convert the wet volume of mortar into the dry volume, right? So the dry volume of mortar is equal to 1.27 times wet volume. Here the wet volume of mortar is 123.80 cubic feet. So the dry volume of mortar is equal to 1.27 multiplied by 123.80 and the dry volume of mortar will become 157.226 cubic feet. So the quantity of cement and mortar will be equal to 1, which is the ratio of cement, multiplied by 157.226, which is the total dry volume of mortar, divided by 5, which is the sum of ratio. Okay. And the total quantity of cement and mortar is equal to 31.44 cubic feet. Also, the quantity of sand and mortar will be equal to 4, which is the ratio of sand and mix ratio of mortar, multiplied by 157.226 divided by 5. And the total quantity of sand and mortar will become 125.78 cubic feet, right? Next is the quantity of sand filling. Okay. Now here first we need to understand what is sand filling and why the sand filling is important in the foundation of houses or buildings. Okay. So if you look at the cross section of this house, this is the width of total excavation or earthwork which are done for the foundation of this house. Okay. And when the construction of PCC layer and brickwork and foundation is done up to the ground level, you can see that I have got an empty space right here because the brickwork is in the form of steps. Okay. Now I cannot leave this empty space because if I did, then settlement will occur in the foundation. So in order to avoid settlement in foundation, I will use sand to fill this empty space, right? And why I am using only sand? Well, it is because the settlement property of sand is 0, okay? Which means that no settlement will occur in sand. So this is why sand filling is important in the foundation of houses or buildings. Now let's go back to our main topic, which is the quantity of sand filling. So the volume or quantity of sand filling is equal to length into breadth into height. Okay. Here I will take total length of the center line, which is 185.5 feet. And for the width of the sand filling, I will subtract the width of step 3 from the width of the excavation or earthwork or PCC layer. Okay. So the width of sand filling is equal to 1.5, which is the width of earthwork or PCC layer, minus 0.75, which is the width of step 3. And the width of sand filling will become 0.75 cubic feet. And for the height of sand filling, I will add the height of these 3 steps of brickwork, and it will become 2.25 feet. as you can see here in the cross section as well. So the volume of sand filling is equal to 185.5 multiplied by 0.75 multiplied by 2.25, and the total volume of sand filling will become 313 cubic feet. So the volume of sand filling for this particular foundation is 313 cubic feet. Next is the quantity of DPC. Now the quantity of DPC is very easy. Here the length of DPC will be equal to 185.5 minus 4 into 0.75 divided by 2, and the total length of DPC will become 184 feet, right? Also the width of DPC is 0.75 feet and the height of DPC is 3 inches, which is equal to 0.25 feet. Okay, so the volume of DPC is equal to 184 multiplied by 0.75 multiplied by 0.25, and the total volume of DPC will become 34.5 cubic feet. Okay, now this is the wet volume of DPC, right? And as I told you at the start of this video that I am using M20 grade of concrete, and the mix ratio of M20 grade concrete is 1:1.5:3, right? Now for the quantity calculation of cement, sand and aggregate of DPC, I have to convert the wet volume of DPC into the dry volume. Now we know that the dry volume of DPC is equal to 1.54 multiplied by wet volume. Okay, so here wet volume is 34.5 cubic feet. So the dry volume will be equal to 1.54 multiplied by 34.5, and the dry volume of DPC will become 53.13 cubic feet. Now I have to find out the quantity of cement, sand and aggregate used in the construction of DPC, right? So the quantity of cement in DPC is equal to 1 multiplied by dry volume of DPC, which is 53.13 divided by 5.5, and it will become 9.66 cubic feet. After that, I will calculate the quantity of sand. So the quantity of sand in DPC is equal to 1.5 multiplied by 53.13 divided by 5.5, and the quantity of sand will become 14.49 cubic feet. Also the quantity of aggregate is equal to 3 multiplied by 53.13 divided by 5.5, and the quantity of aggregate will become 28.98 cubic feet, right? So these are the total quantities of cement, sand and aggregate that will be used in the construction of DPC for this particular house, right? Now in the last, I will calculate the total number of cement bags, total number of trucks for sand and total number of trucks for aggregate, right? So first is the total number of cement bags. Now I have the volume of cement in PCC, volume of cement in mortar and volume of cement in DPC. Okay, so the total volume of cement is equal to volume of cement in PCC, which is 57.48 cubic feet, plus volume of cement in mortar, which is 31.44 cubic feet, plus volume of cement in DPC, which is 9.66 cubic feet, and the total volume of cement will be equal to 98.58 cubic feet. Okay, now we know that the volume of one cement bag is 1.25 cubic feet, right? So the total number of cement bags will be equal to total volume of cement, which is 98.58, divided by 1.25, and the total number of cement bags will become 79 cement bags. Okay, so now I can say that the total number of cement bags that will be used in the foundation of this particular house is 79 bags. Next is the total number of trucks for sand. So for that I have to calculate the total volume of sand. Now the total volume of sand is equal to volume of sand in PCC, which is 86.23 cubic feet, plus volume of sand in mortar, which is 125.78 cubic feet, plus volume of sand in sand filling, which is 313 cubic feet, plus volume of sand in DPC, which is 14.49 cubic feet. And the total volume of sand will become 539.5 cubic feet. Okay, so the total volume of sand is 539.5 cubic feet. Now in order to calculate the total number of trucks for sand, I will need the volume of single truck, right? And let's say that the volume of single truck is 120 cubic feet. Okay, so the total number of sand trucks will be equal to total volume of sand, which is 539.5 cubic feet, divided by 120 cubic feet, and the total number of sand trucks will become 4.49 trucks, and let's take it as 5 sand trucks. Okay, so now I can say that in the construction of foundation for this particular house, I will need 5 sand trucks, right? Similarly, I will calculate the total number of aggregate trucks as well. So the total volume of aggregate is equal to volume of aggregate in PCC, which is equal to 172.46 cubic feet, plus volume of aggregate in DPC, which is equal to 28.98 cubic feet, and the total volume of aggregate will become 201.44 cubic feet. Okay, now as we know that the volume of single truck is 120 cubic feet, so the total number of aggregate trucks will be equal to total volume of aggregate, which is 201.44 cubic feet, divided by volume of single truck, which is 120 cubic feet, and the total number of aggregate trucks will be equal to 1.67. Okay, and let's take it as 2 trucks of aggregate. So now I can say that 2 aggregate trucks will be required in the foundation for this house, right? So the summary of today's video is, in the construction of foundation for this particular house, I will need 79 number of cement bags, 5 sand trucks, and 2 aggregate trucks, right? So this is how you can easily calculate the quantity of earthwork, quantity of PCC, quantity of brickwork in foundation, quantity of sand filling, and quantity of DPC for a particular house, right? So I have done all this hard work only to make sure that you guys understand everything. And in the return, I will only ask, if you find this video informative, then please like this video, share it with your friends, and if you are new to my channel, then please click on the subscribe button, and also make sure to click on the small bell icon as well, so that you will never miss a notification whenever I upload a new video. See you in the next video.